Hello, everyone. Robert Starmer here with Cumulus Technologies, and we're bringing you another episode of the Cumulus Technologies 5 Minutes of Cloud podcast. I'm joined with our fabulous co-host, Lou Tucker.
How do you do?
Hey, Lou. So today we're going to discuss, wait for it, cloud computing. Of course. I mean, what else would we discuss here? But we're really going to focus on a concerning trend that we're sort of seeing, and that is customers are really confused about how they ensure that their cloud resources are secure. Right? So I really want to know, what can I do to ensure that my cloud is as secure as possible? And from that perspective, really, we want to talk about the security perimeter and this idea of zero trust. Right. So, from that perspective, then I think the number one question is, what the heck are we talking about here? What is the perimeter? Where did this really come from? Right.
Well, I think historically, people have always approached networking as, well, the whole purpose of networking is, in fact, to connect things. So You want to be able to have multiple servers and services talk to each other and users talk to those services. But once you do then that, you open it up onto the network, then people look to apply kind of firewall rules to limit the access, or to break a network up into separate VLANs so that their financial systems were kept separate from their HR systems or their developer systems. And that network security model, which is a perimeter-based model, worked for a while. But once you started to, and particularly when you start connecting now your data centers to the cloud, that perimeter model just doesn't work. And you can't rely upon the network alone to enforce the kind of security you need.
Well, in a sense, you've expanded the perimeter into this cloud, this third entity space. And like AWS has security groups, which are sort of little tiny perimeters at the edge of an instance, right? A single VM or a single compute resource of some kind has that security group concept. But that's just one of the many ways of trying to address this and expand this perimeter. Yeah. But I think we both know that only goes so far. Right? Classically, some of the big data centers that we both interacted with, it's exactly what you do. You'd set up your firewall. You might have segregation, but a lot of the companies I worked with, they had firewalls at the edge, or they had firewalls at the edge of their entire corporate entity even. Right. And everything else was basically wide open.
Particularly, today that we see a big movement towards working from home, you want to be able to have some of your key employees working from their own home networks and everything else, and accessing now corporate resources over the internet. So immediately you have a conduit by which malware and spyware and bad actors can break into the weakest link in that and get into all of the corporate assets.
Right. People would set up a VPN. So now your laptop and potentially your bring your own device is now part of that same bubble, right? So that same bubble that's reached out into Amazon or Google or what have you. But that device potentially has its own security flaws, right? So we've previously talked about other issues or other concerns. People have talked about like some of the big breaches. The two that I think we talked about recently, one was Target and its massive loss because somebody was able to get inside that perimeter. Right?
Exactly.
And then there was the SolarWinds had their flaw where one of their employees broke their tools so that they could effectively get access to anybody that was using that platform as a way of defining their perimeter.
Right. And therefore, all of SolarWinds customers were then at risk.
Right.
So you really need to constrain what, the attack surface. That's what we talk about in security terms. And when you get more and more systems involved and more your systems connected to your partners' systems, connected to your suppliers' systems, it becomes totally unenforceable at the networking level.
Right, and even at the edge device level, right, you can incorporate that device in through a VPN, but you've still given effectively the entire infrastructure of that device access to your corporate network. So, what are we doing to address that? How have we addressed that in the industry today? What's the tooling that we're talking about, right? Which is effectively What's zero
Well,
trust?
I think the trend we're seeing today is something that essentially was really promoted by Google many years ago. And it started something called Beyond Corp, and now people talk about it as zero trust. And
Right.
what this really means is forget it. Don't trust anything. Have no trust in just somebody being on your network, so that they assume that there's going to be bad actors on the networks themselves. And instead, what you really have to rely upon is being able to authenticate who's accessing or what service is accessing things. And in front of every application, you have to have a way to check those credentials and everything else to protect the resources themselves, leaving aside the network, because the network, you have to assume a bad actor could get onto it.
Right. So if you're now protecting effectively at the application level, right? I think for a client, the classic application now is a web browser, and given the way web browsers work today, it's actually the individual tab within the web browser, that little virtual machine is the thing that we can now authenticate and create an identity.
Mm-hmm.
But I mean, classically, identity is username, password, right? I mean, so is that adequate? Is that the kind of identity we're talking about here?
Yeah.
How do you
Yes and no.
identify it?
I still think that's almost the weakest link in what we do with social engineering. People's very weak passwords that they use. We've moved now to two-factor authentication,
right?
Either through devices or a secondary device, another computer or a phone or some other thing, to improve the ability to have an identity that you can trust.
Right. Right. So now that we have a known identity,
but I think so it's
two-factor authenticated.
Yes.
The other part is still, how do I then authorize that user, right? So how to make the connection? Username, password, yes, it's still a weak link. And now there's some work going on in terms of like passwordless authentication, which is still a two-factor or multi-factor authentication. You're still trying to authenticate the device and the user together, right? So there's some piece of hardware in there. So if we just sort of take it as viable that we can now identify somebody, I think the next question is sort of around authorization and authentication, right? So we've said we know who you are, but what does that mean in terms of what you can do, right?
Exactly. Because now that authentication service or system is where the policies around whether this person has a legitimate reason to be making a query against this financial system or a database, and that's determined now by policies. So you have to have a place to store all those policies. And what was actually kind of remarkable about Google's approach is that they say they're going to centralize that whole system, logically centralized. It's spread over lots of servers.
Right.
But that when an employee leaves because they may have been fired, or a new employee comes in, they can be granted the access to all of the systems that they need to and cut off from anything else that they don't need to.
Right.
That puts a lot of now burden on that point that connects to an application. And therefore, we have to watch how complex we make this, because then we're making the developer's job much harder.
Absolutely. So, I mean, we talk about this as a human, right? So a user can have a password in their head and they can use that, right? In the machine world, that's often a token that we grant somebody, and managing secrets and making sure that your tokens are still secret across the platform, much like your identity is controlled, is another, I mean, that's a whole nother ball of wax in a way, but it ties into supporting infrastructure for this, right? Secrets management, identity management, like the identity services are really critical to people being able to make use of cloud. And we see all the cloud providers now have their own identity tools, as well as there are third-party software as a service type identity services. Like Okta, I think, is the most popular at the moment for that kind of tooling. But you're right. So we've defined how we can do this for users. There are models like token-based models that can provide the identity and at least the concept of who is this application that wants to talk into this infrastructure. But everybody's writing in different languages, right? Now, I mean, I thought Rust was the new language, and apparently Rust is now old, right? Rust is ancient. Well, I mean, yeah, some people may still use that, but now can't even remember the Julia. And,
exactly.
Like, all these new languages come along. Each one of those would have the same need to be able to manage through the same authentication process. How do you validate that it's that same device? All of that sort of stuff. And I think your point here is, there are other tools, namely proxies, that we can actually start to look at that can help implement the identity and authorization component of the zero trust model.
Exactly right. Because particularly then when you look at, you have got legacy systems that were designed, may still be running, that haven't been changed in 10 years. And yet you don't want to have system administrators go in and put in new logins and passwords for every user into those old systems. So we need it. I'm reminded that in computer science, we often solve a problem by adding another layer of indirections. and that makes things much easier. So I think that what we're seeing today is the use of things which are these proxy servers, something that sits in front of every application. So applications themselves are never accessed directly. They need to be accessed through a system, through a proxy server or something that can check the credentials and make sure then that the person has the appropriate rights and privileges in order to come into that application. And then the application can do their own. They may have a whole nother level at the application level. If it's a database, generally have their own trust within the database. But front ending that keeps the bad actors out, and they don't even have a chance to now start to attack your databases.
Yeah, and if you're using something like the containerized environments, like a Kubernetes management layer, or even just a container management system where you can redirect the network traffic, right? That's, to me, it comes back to that perimeter that we were talking about to begin with, right? The perimeter is now at the application component, whether it's containerized or, like you said, it's an older Windows machine running a piece of software that's maybe a little bit long in the tooth, but is still core to business. I mean, every customer I've ever talked to is like, well, yeah, we want to do all this new fancy, cloud is the future. Yeah, isn't it great? And then they say, oh yeah, we have 14,000 machines over there that we can't touch, because the developer who wrote some library is long gone and we don't know how to fix it.
Exactly right.
So how do you address it for that? So the idea of a proxy in front, of course, this does add a layer of management overhead, right? So now I have to make sure that the proxy is authenticated and can provide authorization. I mean, the whole TLS world, the SSL, HTTPS service environment really helps, because so many applications over the last 15 to 20 years have transitioned to that HTTP-based method of communication, right? Even if it's not necessarily a RESTful interface or something else, it is still using that, and it's using TLS as its security protocol inbound. But now there's the inverse of that, right? Which is the mutual TLS. So now I can authenticate that client, which is the gap I think that was missing for a lot of these sorts of services. But again, as we were talking about, increasing the developer's burden by saying, oh, you now have to implement a mutual TLS service, map that back into your application, adds this overhead. So if we can do that in a proxy, that's great. But the proxy still also now needs to be managed, right? And that's
exactly right. But that's where, and also now it allows you to sort of readily use cloud-based resources as well as your own data centers resources, because you actually have a system, a network of these proxies that are sitting in front of all of your applications and services, whether they be in the cloud or whether they be in your data center. And that gives you the freedom to use automation to do this in a consistent way for everybody. And it offloads all the responsibilities from the developer. The developers, because that's probably one of the weakest links, is that a new service comes on, it may or may not be going into production, but it goes out into a production environment. And you formerly had to have security personnel look over all of those new applications, and you still want to do a fair amount of that. But now, by having a proxy in front of it that's managed independently of the application, you can ensure that that proxy is doing the correct authentication services that it needs to.
Yeah, and there are actually two proxies that we're starting to see here that fit into this, right? One is the service mesh proxy, which I do want to touch on at least a little bit in this conversation, even though that's probably a whole other
thing onto itself.
But but there's also the API gateway, right? And so for new applications, you can actually do this boundary, and you can set this boundary up at the API gateway layer. So you can say, yes, I'm going to have one device or one service that provides this. Again, it's like the mega proxy. So it sort of centralizes the automation in that case. And that's one approach. And that gives you then the new perimeter, right? That's like the new web perimeter is the API gateway now. And we're seeing this. I mean, if you get into the Kubernetes space, you have to have an API gateway to get into the Kubernetes environment to connect the outside world into your application space anyway. So it's effectively been forced on a lot of developers. Yeah. But again, to that same management perspective, right? I can automate this. I can define the fact that, yes, I need this particular HTTP path. This URI is going to connect to a piece of my application. And I have a lot of control now over what that is. When I add on top of that identity and authorization layer becomes really, really powerful.
Right. And most importantly, we're now talking about it as identity that's represented by certificates and other identifiers rather than IP address. Yeah. In the previous world of VPNs and firewalls, there was always IP addresses, and that we know is not sufficient anymore. So now it's really the identity that becomes important, and you need to have now your identity management system taking care of that and communicating to all of the proxies that are set up there. These virtual software-based firewalls, so to speak. But they're based upon identity rather than just an IP address. And they may have lots more than just that. It may also be whether the machine is trusted. Yeah. I mean, can you have a laptop that is a corporate laptop that you gave to an employee, and that can be identified, that can have a root of trust on it? So it's many, many factors that can go into this identity.
Well, and the additional component is that once I've put a proxy in place, and once I've put a tool, like, again, even a service that gets downloaded onto the local machine as a part of a web applet that's running in a secured component of your web browser, now suddenly that can actually do things like key rotation. So that token that we talked about briefly as the machine password, that token can be rotated automatically. The end user has already authenticated. The token gets rotated. So if somebody steals that token, it's only good for a very short period of time. In some cases, I've seen tokens that last just seconds, basically on a almost per transaction basis. That's a little on the extreme side, but it can be done. And I think the key point there is automation is the thing that drives all of this. Much like I think our previous episode, we had talked about how really cloud is all about automation. In this case, I think it's even more critical that all of these things are automated. We can automatically inject these proxies in front of our services. So if you spin up a new service, even a new old service, if you spin that old service up manually, yes, you manually have to make sure that you've enabled the proxy, tied it in, connected it to whatever services. But if we're automating that using state-driven protocols like classic Ansible or Puppet sorts of things, even in the older school systems, we can still get the same kind of enforcement, the same kind of zero trust capability.
Right. Without burdening the developer. The application developer should not have to be a security expert. The application developer should be worried about the user experience and the scalability of their code or their cluster. Those are the concerns of the application developer and the site reliability engineers. But then it's the management system that puts them behind these protected resources, which are basically having these proxies that do authentication and make sure that the entity that is coming into that service now is known and has permissions.
Yeah, absolutely. I mean, I think the automation key is key, and the service mesh is the other piece of this puzzle. So we talked about API gateways just briefly, but service mesh is the other piece of that, and this works potentially. You had mentioned, hey, you spin up a new service in the cloud and it presents potentially a web style interface or HTTP interface, maybe through an API gateway, or maybe it directly is the API gateway itself, which is, I think, for a startup application, the more likely scenario. I just spun up a Python Flask app. It's a web server. It can present itself. It doesn't need anything else. But if I can auto inject a proxy in front of that, and if that auto-injected proxy is also automatically being configured, and this is, I think, really the realm of the service mesh. So you'd mentioned Beyond Corp, and I think a core piece of that tooling by Google was Istio, which is an open source cloud native compute foundation tooling around managing all these little proxies that potentially live not only within one domain. Right? The first place I saw service mesh was inside of a single Kubernetes cluster. Right, because people were talking about, I need to tie all my microservices together. But now we're starting to see that expand beyond, right?
Yeah. So I think it's interesting sort of development in the last couple of years as we've seen the division of labor in terms of deploying a service, particularly if it's a public-facing service. We need to be able to manage the scalability of the infrastructure behind it, how many servers, virtual machines may be spun up. We need to be able to handle the security. We may have to be able to redirect traffic because you need to balance load. All of those things are no longer in the province of a application developer. They really are in terms of a system developer who's developing the automation that allows these processes to do all these functions, letting the application developer again focus on the application, making that the very best, while these other system properties are managed independently.
Yeah, I mean, I think this division between the application developer who needs to focus on an increasingly complex application and the business logic and the real value to the company, right? The features that are being demanded by their customers. The features are not, oh, give me identity management and auto authentication and all that, right? They usually want, something that drives their business forward instead. But being able to automate the injection of this automatic security protocol, right? So this whole idea of zero trust, allowing access. I mean, some of the new style VPNs, which are effectively zero trust VPNs that are out there, are also pretty amazing because they use that same thing. I'm going to stand up effectively a proxy that's going to redirect network traffic locally through a tunnel to a remote location, also potentially through a tunnel endpoint to get access to services. But you can tie this directly into a service mesh as well. And suddenly your VPN model, I logged into the VPN, I'm connected, I have access to a whole set of resources that are using that same authentication mechanism, the same identity mechanism for driving. So it suddenly becomes really, really important and really powerful.
And of course, you still need to have your security team examining all of that.
Right.
I think that will always be true. And you also have to have people who are enforcing policy and looking at those policies and keeping those policies up to date. It's no longer the network engineer who's logging into a firewall and changing firewall rules. It's now somebody really approaching it at the abstract level of who has permission to see what resource. And and it might be down to the level of the individual, but you might say a group has permissions to this. And just because somebody has a senior executive title doesn't mean that person should have rights to get into a particular service. As a matter of fact, it's usually dangerous if you do that.
Well, and often, the old methodology of, hey, let's get somebody to manage the firewall. Now there's a human being that has access to and can make a mistake, right? I mean, that's the other sort of part of this, the automation and automating that access control and basically removing the manual firewall configuration and defining it as policy. Yes, you have to have somebody review what policies you're compiling, right? Because that's going to be key. That's going to drive a lot of this. You have to review who has access based on those policies that you're creating. To your point, that's your SecOps team. And especially now it's DevSecOps. So hopefully even that's being mostly automated. At least you're doing some validation checks automatically on changes that are being proposed. But you're managing by policy. You're not managing by change of individual code lines, right? And you're no longer managing by IP address, right? I think one of the things that we've both seen in the past is, I've got this whole host table because it's these IP addresses that I want to get to. I want to use a name, but I don't have a name system, domain name system. I don't have a domain name system set up for within my environment. So I'm going to create this point-to-point policy model where it says, if I know this host name, or more importantly, this IP address, I can get access to a service. We know that's a failure mode, but that's how firewalls are managed, is by IP address or IP address range. Right? So you're doing policy at the IP address range rather than policy at the identity range.
That is trying to protect the network. And or to use the network as protecting your resources. And we know that just really is not the way anymore.
Yeah. Well, as we've discussed, right? So there are all these other tools. I definitely want to get deeper into service mesh because that's not just useful for this zero trust component, but can also be used for all kinds of developer acceleration and feature enhancements within that environment. I'd love to talk to you more about that.
Exactly.
But we're in a sense we're sort of out of time for today. So hey, look, again, thank you for your time and reviewing some of these ideas. You can always find us, the the listener, thank you for listening. But you can always find us on your favorite podcast channel. You can also come check us out on our website, kumul.us. That's Cumulus. Or hit us up on social. We're Cumulus Tech on Twitter and LinkedIn. I'm R. Starmer, and Lou is Lou Tucker.
I'm Lou Tucker.
Yeah, so easy to find us. Obviously, we'll post all this information on our show notes. So until next time, this is Robert Starmer.
Great to see you again. Lou Tucker here.